Everybody see my screen?
Looks good.
Cool. All right. Thanks, everybody. Well, welcome. So as Nicole stated, my name is Jason DeMoss. I work for ECT. I have been in the industry for a little under 10 years. I'm based out of Ann Arbor, but I'm actually in Marquette, Michigan right now. And so without further ado, let's get started. So I will be discussing antecedent precipitation. So the way that the presentation works is I will first define what it is and provide reference materials. And just so everybody is aware, I will provide all this information. So I'm planning to send out this presentation to everybody because I do have links in the notes. And so if anybody has any questions, they should be able to access this presentation. So I will then go into what the purpose of antecedent precipitation is. And then I will show how you would calculate antecedent precipitation manually. And actually the US Army Corps of Engineers has their own what's called Antecedent Precipitation Tool. So it kind of takes the heavy work out of calculating it manually so that it kind of does it for you. And so without further ado, I'm sure you all are wondering, what is antecedent precipitation? So it is the precipitation falling before but influencing the runoff yields of a given rainfall event. So it's typically used in calculations for things such as water budgets, runoff, meteorology, and if a drainage basin or watershed is considered wet before a storm, more rain is likely to run off, which would then lead to flooding. So it's also used as an indicator for soil moisture and soil runoff. And so, like I said, it provides you a summation of daily precipitation amounts compared to the moisture stored within the soil before a given rainfall event. And so these definitions were taken directly from these reference materials at the bottom. And like I said, when I send out the presentation, it'll have links to each of these items at the bottom of this slide. And so you probably are all wondering, why do we use the antecedent precipitation tool? So it can be used to evaluate whether you perform a desktop evaluation or a field delineation, and whether your features on a particular date or set of dates are representative of relatively normal wet or dry conditions. And it has many uses other than doing what we do for wetland delineation and identification. So as you can see in the photograph here, this is an example of a site. So for example, if you went to the site in March 2019, that could have been considered a more wet time of year relative to the past 30 years of precipitation data, versus if you went to the site in June 2011, maybe the site was very dry at that time of year, or maybe say October 2013. So like I said, the other typical uses of antecedent precipitations, it can tell you things such as a typical growing season, current drought conditions in a given region that you search, the last rainfall before your delineation, and it has many other things besides just, like I said, our wetland delineation. So you can do watershed flooding calculations, runoff calculations, meteorology, model building, stormwater water budgets, mitigation monitoring, wetland creation. And so next, so this sheet that's here on this screen was taken from I believe the NRCS reference that I had 2 slides ago. And so to calculate antecedent precipitation, you would need the normalized precipitation over a 30-year period in conjunction with the precipitation occurring 3 months prior to the photograph date or delineation date. So I know that sounds like a mouthful and it's just a blank table, but the following slides that we're going to go through will show you how to fill out this table. And so keep in mind that there's also an automated tool that will do this for you. But to understand how to use that tool and the result that you're given, we need to know how to get there. And so after you would end up with a table that looks sort of like what's on the right. And so actually this table right here is taken from the Minnesota Bowser. And so this table is actually just like a direct copy from the Minnesota Bowser, which I think is like the Board of Water and Soil Resources. And they have a website also that will do it for you if you ever do work in Minnesota. And so first, to calculate the precipitation manually, you would go to NOAA's Ag ACIS weather station website. And so it'll give you a printout of 3 months of weather data compared to a 30-year average. And so you will get what's called a WETS table. And so what that is it's a climate analysis for wetlands table. And so again, it's a month-by-month summary and probability analysis of temperature and precipitation for a given weather station. And so the table will provide you with the first and last dates and the length of a growing season using index temperatures of 32, 28, and 24 degrees based on a 50 and a 70% probability. And then a third table that will be printed out provides the monthly precipitation totals for any given period. And so let's do an example project. So let's say that we have a project in Hillman, Michigan, which is in the northeastern Lower Peninsula. And let's say that we go to the site in April of 2021. So when you go to the Ag ACIS website, this is sort of what it first looks like, this blank page where it says here, state, Michigan, and then you have to select a county. So Hillman is in Alpena County, or actually it's not in Alpena County, it's directly west. And so when you go to the Ag ACIS website and you click on the WETS table, you first have to select a weather station. And so the big issue with the weather stations is you have to hover over each one. And if it has a precipitation date range that is not somewhere between the past 30 years, it won't give you the data that you need. So typically you'll have to choose a weather station like at an airport or at a fairly large city. So for example, if you're in Kent County down in Southwest Michigan, you'd probably need to use something like the Grand Rapids Airport or a City of Grand Rapids weather station, or same for Southeast Michigan, you'd probably have to end up using the Detroit Airport or the Saginaw Airport, depending on where your site is located. And so in these screenshots, I have an example of you would use the past 30-year range, and the nearest weather station to Hillman ended up being Alpena Airport, and it had this precipitation length at the bottom right that you see. It started collecting data back in 1916, and it still has data. It's still collecting data to this day. And so once you hit go, it'll give you this big printout and it'll present all these numbers. And so it might be a little overwhelming. And so I'll show you the important things that you need. So you want to see this 30% chance will have less than or more than. And so this is comparing the last 30 years of precipitation data. So for example, in January, based on the last 30 years of data, it's saying that given any time in January, your site will be in the normal range if it's between 1.14 inches of rain and 2.17 inches of rain or precipitation. Sorry, it's January, snow. And so again, we went to the site in April 2021. And so your first month prior is going to have 1.03 inches. Your second month prior would have 1.01 inches. And your third month prior is going to have 0.66 inches. So now converting this all into that fancy blank table. I'm just going to have arrows here that show kind of where each number would go. So here's your 30% chance less than and your 30% chance more than. And so then the table from the precipitation data will end up in this top row. So again, we're just moving numbers back and forth. So 1.03 inches, 1.01 inches, 0.66. And then this is once again just copying these numbers over. And so because we were in between the 1.03 and the 2.19 for your first month prior, that's considered a normal precipitation range. Because we were also between the 0.96 and the 1.79, we were also once again normal for the second month before our site visit. But because we had 0.66, which is significantly less than the 1.14, that's considered dry. And so again, here at the bottom, we have what each value means for its given weight. So your first month prior has the largest weighted score. So normal is given the value of 2, and dry is given the value of 1. And if we were wetter than normal, we would have a value of 3. And so because this site adds up to 11, our delineations say that we went there again on April 8th, 2021. It was in a normal antecedent precipitation. So compared to the last 30 years of precipitation data, we had a fairly normal site visit. So essentially the wetlands should represent what it would look like compared to the past 30 years. And so that long manual calculation that I just did, prior to 2019, there was no software available that would do this for you. Outside of the state of Minnesota. So again, in Minnesota, Bowser has their own way of doing this, but we're here in Michigan. So another pro of doing the calculation manually is it doesn't rely on errors in computer software or coding, or if your computer system is down. If you're familiar with how to do the calculation, it can be performed relatively fast, maybe even faster than the Antecedent Precipitation Tool from the Army Corps. But your cons would be that doing this calculation manually, it relies on only one weather station, whereas the Army Corps' tool can do multiple, it can pull multiple weather stations and code all of that information in the background, maybe while you do other work. And again, in doing this method, it's more based off of a month by month, whereas the Antecedent Precipitation Tool from the Army Corps will be run on a day-by-day basis. So I'll show you later on in this presentation that this calculation ends up being different because I was only able to do it based off of the months prior to April, whereas the Antecedent Precipitation Tool could do it based off of specifically April 8th and April 9th, which is when I was at this specific site. So to download the tool from the Army Corps, and again, I will send this presentation out and it has links to all of this information. And so you'll end up going to the EPA's website, and it'll link you to this website called GitHub, which sort of has all these different coding tools in it. And so it's actually pretty straightforward. You would just end up downloading a zipped file. And when you unzip it, it just ends up looking exactly like how it does here on the right. It just makes a folder, and then this is the tool itself at the top right that you see. And so once you open it, it just asks you every single time that you have to accept the agreement. And so like I said, it is provided as is. And so there could be errors. This is pretty much what it's saying. And I'll get to that later on because there were errors in the software earlier this year. And so again, once the software is fully open, this is exactly what it will look like once you double click that icon and when it comes up. So again, this was earlier this year in February. There were errors in that it couldn't run your site with multiple days. And so you ended up having to do it one at a time. And it also had issues with formatting on the page, but these have all since been fixed. I contacted the Army Corps. They were super quick actually to fix all the issues. And so here's the latitude and longitude of Hillman, Michigan. And so again, we were pretending that we're at the site on April 8th of 2021. And so what it does is, as you can see here, when you hit calculate, it'll do it all automatically. It'll just search for all these stations within a 30-mile radius. And then it just automatically, again, just starts downloading all of the weather station data and puts it into just Excel sheets in that folder of the screenshot that I had earlier. And essentially, once it's done, this is what the file printout looks like. And so, it provides you this really nice graph showing the precipitation data, and this yellow represents the 30-year normal range. And again, the calculation that I showed you earlier, because of the way that the WETS table prints out, it pretty much does it on a month-by-month basis. So that would have been the equivalent of going to the site on April 1st. So because this specifically went on April 8th, it was able to pull the month prior of March 9th and then February 7th. And so the values were slightly different. So, on March 9th specifically, it was able to tell that it was drier than normal. And then on February 7th, it was also able to tell that it was drier than normal. So actually, when I did this site visit, the antecedent precipitation conditions were drier than normal. And so again, this is just comparing the two, because when you do the WETS table from the NOAA weather station, I mean, you could end up going through and manually going through those long Excel sheets of weather station data and trying to pick out the exact 30 days prior to specifically April 8th. It's just the WETS table kind of puts it all into a month by month printout that's easier to view. And so once you're done with the data, it just saves it all into a folder based off of the Latin long of the site that you went to. And again, it gives it in a PDF and an Excel format. And just going back, the PDF, this is exactly what it looks like. And then the Excel format is essentially this table that starts with this 30 days ending. And so that's what the Excel printout looks like if you wanted to copy it into, say, like a report or an email. And so that's pretty much how to go through the tool. And so I guess we'll start with the question and answer section. Nicole, if you wanted to do that.
Sure. Thank you for sharing that information with us. I have yet to receive any questions in the Q&A function. So if there are listeners out there that have questions, please quickly type them in now so I can dictate them to Jason. In the meantime, I guess I can ask a question of my own. So that lovely printout, the figure that is generated in the PDF. So if if you were on site on April 8th and the blue line for that day falls within the yellow band, the precipitation was within the normal range.
Correct.
Okay.
Yes. So that's specifically on April 8th. And so this antecedent precipitation, based off of how it's defined in those references earlier in the presentation, they all say that you have to do it based off of the 3 prior months, with the first month prior being the highest weighted. So even though specifically on April 8th, or the 30 days ending in April 8th were normal, the 2 months before that were dry. And so because those two ended up having a heavier weight than specifically the month prior, then the overall site visit was considered dry.
Okay.
Drier than normal.
Okay. All right. Here's a question. Is there any way to plug in multiple days into the APT?
Great question. Yes. So let me go back a few slides. So as you can see here on this slide, there is a plus button right here. So if you wanted to do, say, like April 8th and then do April 10th and then do April 12th, and then you can also do a date range. So if you were at the site specifically between like April 8th and April 18th, it'll do all of that manually for you.
Okay, it's good to know. Let's see here, another question. If precipitation is not within the normal range, how does that affect your wetland delineation or site analysis?
Yeah, that's a great question. So, it's all on I'm going to go back a few slides to the pictures. So, so again, that is a great question. So here, let's pretend that this October 2013 and March 2019 are in the same year. So for example, you can see a huge signature here that happened in March, and let's just pretend that this was wetter than normal. But then in October, this was considered under normal conditions. So it essentially, and again, I have no say over Eagle Authority or Army Corps Authority, but if you went in March 2019, it was considered wetter than normal. using the antecedent precipitation either to your client or to Eagle, it can help you essentially say like, maybe our wetland boundaries are larger than they're supposed to be. Or if you went on a drier than normal condition, our wetland boundaries are maybe smaller than they're supposed to be. So for example, here again in October, you may have a small little wetland here, a small one here, and another one here, but then in March, it might just be this entire area. So it's sort of a project by project specific instance, because I'm not specifically sure on each specific site is different. So I know that didn't fully answer the question, but essentially in a wetter than normal condition, maybe your wetlands are a little bit larger than they're supposed to be, or you may find more wetlands than if you were typically at a normal or even drier condition. So then again, if you're going in a drier condition, your wetlands may be smaller, or you may find less wetlands than you normally would.
Okay, thank you. Couple more questions here so far. Which scope test do you choose when running the APT?
Which scope test? I typically do. Is that specifically related to, hang on, let me go back to my screenshots. I typically just do a single point, because I think if you do an area, it makes you upload a shapefile. But typically in each instance where I've done single point versus an area, or I'm not sure if it does a line, it usually provides the same results. Because typically, like I said, if you're in a rural area or a less developed area, the nearest weather station that has usable data may still be like 15 or 20 miles away, and that may be the only weather station.
Okay, next question here. Because sites close to the Great Lakes can have a very different climate from interior locations, can you force the APT to use particular stations?
I've never been able to do that, because the way that the tool is built is that it essentially just pulls in any weather station within 30 miles. And also one thing that I briefly touched on is, when I had this issue, when I had the issue with where it couldn't run multiple days, I reached out directly on the GitHub website, and the Army Corps responded very quickly, which I was surprised about, and they actually emailed me directly, based off of like my GitHub account. They emailed me directly and they were like, hey, I saw your comment and we're making the change. And then 2 weeks later, they were like, we made the change as well as these other bug issues that we had. So yeah, that could be a great question that you could ask directly to the Army Corps about manually choosing weather stations, because I've never been able to try that before.
Okay, thank you. Another question. You mentioned the APT had uses outside of determining normal wet or dry conditions. Could you please elaborate on that?
Sure. So so the reference that I had, hang on, let me go back to the printout also. So it does provide things such as the current drought index and the web WIMP water balance. I forgot what that acronym means, but recently in a report, I had to, write about what those two meant, because it does tell you whether you're in a drought or whether you're in Michigan's wet season or our dry season. So that's slightly different than the antecedent precipitation. So the wet season would be something like, our springtime versus August. That would be considered our dry season. So it can tell you that information. And then when I send this presentation out and it directs you to the link to the hydrology tools for wetland determination in the NRCS engineering field handbook, that also tells you how to do it for like runoff calculations, or how you can use this information for like mitigation monitoring, or other wetland monitoring projects. And actually, I believe that antecedent precipitation itself was developed specifically for for meteorology monitoring first, and then we sort of adapted it for our uses.
Okay, next question. Are regulators asking to see this data routinely now or even requiring it?
So I can't speak specifically to Eagle. You know, I do know of people for if Eagle has had questions about like the validity of a delineation, they've used this information to show whether their delineation was valid or not, and it has helped. I mean, I do know most definitely different Army Corps districts do require this. I know this is like Michigan specific, but certain Army Corps districts do require this information. So like I said, Minnesota specifically, they're the ones that first developed a tool specific to Minnesota. They require this information. I know that for a fact. And certain other Great Lakes region Army Corps districts do require this information when you submit a report to them. I can't speak specifically to Eagle, but the information doesn't hurt. You know, providing more information does help provide additional context to regulators.
Okay, thank you. Here's the last question in the queue. If a wetland delineation is conducted under drier than normal conditions and during the growing season, can you defend your delineation, or would you have to get data from other resources to support your work? So I think I'm interpreting this question to say, is data generated from the APT enough to support your delineation?
I believe so. You know, it's just one of the many tools that we use. So another thing you can do, I know, and I'm going based off of work that I've done in Minnesota, you know, you can do a comparison of the past of all the aerial imagery that's available on Google Earth. So, you know, if every year that's available on Google Earth, you see kind of the same wetland signature, that's something that I've provided in like a pre-app meeting or a JPA before. Or you can also provide, you know, this was the only time that we could go to the site, or overall the whole year was drier than normal. So there are many other things that you can provide. So again, this is just one of the many tools in the tool belt that we have, right? So it shouldn't be taken as like the definitive yes or no, whether your delineation was valid or not.
Okay. So if there are any other questions out there, please quickly submit them to the Q&A function at this time. We'll pause for a few seconds here to see if any more questions come through. Okay, it looks like that about does it for questions. So thank you, Jason, very much for sharing this information with MWA members. I'm sure it'll be put to good use. And like you mentioned, we'll work on sending out your presentation slides to all that registered for this webinar today so that links are readily available. And with that, thank you for attending, and I hope you have a lovely rest of your day.
Thanks, everybody.